hello everybody. As Ben said, I am Jaime Jones. I'm a lead, that's good. Okay, better. Lead front-end developer at Ritter Insurance Marketing. And I do have these slides online if you would like to follow along. So I'll leave this up for just a minute because this URL is not on all of the slides, so everybody can kind of get there. But go over what we're going to be talking about. Most of this is going to cover the Vue Lifecycle and the Lifecycle Hooks and when to use them, and kind of some neat tricks that you can do with a couple of them that you might not really use otherwise. And then at the end, we're going to kind of jump into just a couple of other tools in your Vue arsenal, like nextTick and v4, which we probably all use frequently, and then refs. And a disclaimer on this is covering Vue 2. Most of this should still apply to Vue 3, but there might be some subtle differences. I'm not sure because it's not out yet, but I'm looking forward to finding out. All right, so we'll go ahead and get started. So the Vue lifecycle begins when your Vue instance, your component, initializes. It goes through a cycle as observable data changes, and when your component is destroyed, it has an end. So we're going to actually look at the lifecycle diagram, and I know this is a lot, but you don't have to stress. We're going to actually go through this piece by piece on bigger images, so you don't have to try and read all of this. But I just wanted to put the lifecycle up there so you could see there is like a clear beginning, there's a clear end, and then all those red outlines are the lifecycle hooks that we can go ahead and like run our own code in, which brings us right into this next slide. Those lifecycle hooks let us hook into those different points in the lifecycle and run our code so we can kind of keep track of what's happening in our component and react to that. There are a lot of hooks, but don't stress about this list because we will be going through each of these. And again, this does not cover the new ones that will be in Vue 3. The first two that we're going to look at are beforeCreate and created. And you can see that the component initializes when we call new Vue. Then we get beforeCreate. And then we actually get our injections and our reactivity and created. And as Greg went over this morning, setup is called in between beforeCreate and created. And so if you're using the composition API, you probably do not need these, but we'll go over how to use them anyway. So on beforeCreate, this runs before your instance has really set up any of that data. So we can actually console log this, and we do get the component instance back, but it doesn't have any of the things that we would be using on it. You have like the node ID and things like that, but if we try and console log this.foo on this example here, we would get back undefined because that data has not been set up yet. This brings us to created, which you will probably use a lot more, and this is the best part to be populating your data. You now have access to data, although your Vue has not actually re-rendered yet, but this is a great time to start making network calls to populate data. In this example, we can see that we have an application that takes in cupcakes, and now that we're in our created hook, we're going to call and get the cupcakes. This is a good point to do this because you can get those network calls out sooner, so the user has less of a perceived wait time after the DOM re-renders. Also, beforeCreate and created are the only hooks aside from errorCaptured that will run during server-side rendering. So after we have our created and our beforeCreate, we have beforeMount and mounted. And we can see in this piece of the lifecycle diagram, we actually go through and start compiling things into the render function, and then we get our beforeMount. But we have not actually re-rendered what is on the DOM yet. We do that before our mounted. And we'll see some examples of the differences here and some really cool things that you can do with that. So beforeMount is one that you may not use super frequently because it runs before the DOM has re-rendered. But here's an example of something really neat we can do where I'm sure that people have been in a position where they've had to make an application that needs to be embedded somewhere. And you might need to take in data from that outside application that it's embedded in. we've had this situation ourselves, and we've used outside libraries to deal with it. But here's an example that you can solve with beforeMount. So in this example, we can see that we have our ID, and then we actually have a data set item on there of a dessert with a cake. Our app takes in whatever we're currently serving, and it's set to default to serve spaghetti, but I'm kind of more in the mood for cake right now. So our template just goes and shows whatever we're serving. In our beforeMount, if we console log our $EL, we can see that we're still getting back that ID of app before anything re-renders. We're not seeing our serving, we're not seeing spaghetti. And the really important part here is we have access to that cake that's on that data set. So we can actually go ahead and set our serving to that dessert that we've set on our data set, and then in our mounted, we'll actually see that when we re-render, we have cake instead of spaghetti. So this is a great way to pull in data from outside without needing to rely on the window object. And it doesn't even matter that it's going to get obliterated as soon as we get to mounted, because we've pulled it in and we're good. Mounted is where I used to call to get all my data, and then I realized that that creates longer wait times. Mounted is ideal instead for accessing and setting up outside libraries that need that DOM to already be re-rendered. So in a simple example here, we can see that we have my chart as a div, and then we've maybe called and gotten all our chart data and our chart options set up, and now we're gonna integrate this outside library, Chartist, to get our chart set up, because we know that DOM's not gonna be re-rendering here. Mounted is also good to not make a bunch of changes to your data if they can be made and created instead, because you can have situations where children components can be relying on things being set a certain way, and you might have computeds in a child component that are erroring out momentarily. So if you do all of your data manipulation that's possible in created, it's just a safer way to go. So after our component is mounted, then we start this observable data cycle where we watch for data to change, and then we have beforeUpdate, which goes before we actually re-render for that change, and then updated, which runs after we render for that change. We can see the differences here. In our beforeUpdate, we have an example with a counter. We just show the count, and we can click to increase the count. So when we click to increase that count, beforeUpdate will immediately run. And we can see that our count has updated on our data, but if we actually check the DOM and look at the text content of that counter, it has not updated yet. So we can see that the DOM has not re-rendered at this point. On the flip side to that, in updated, we have the exact same example, but we can see in our updated hook, the DOM has re-rendered, and we have that matching data there now. BeforeUpdate and updated are not a good place to try and track specific changes in your data. Those are better off handled in a watch or a computed, because this is going to run when any data in your component changes. And instead of having like, oh, well, if this one was changed, just do it in a watch. It's better. This is somewhere where you would do like analytics, send out things like that. And then once we get to the end of the life cycle, that's where we're going to start to break this down, and beforeDestroy and destroyed, or beforeUnmount and unmounted, I think, as we heard this morning. So beforeDestroy will run while your instance is still fully functional. And then we start that teardown, and then at the very end, we get destroyed. So in this example, we can see we're going to actually have that instance still available to us. So we're going to maybe emit out to the parent and say, hey, this item was deleted successfully, or whatever. So you can show a message, yes, you really did delete this thing. It's OK. And just kind of move on from there. But this is the point where you want to send any messages out, do anything that you are needing the instance still functioning for you. Destroyed, on the other hand, is an ideal place for any final cleanup, such as if you've added event listeners to the document or the window and you want to remove those. And you should be removing those, because otherwise they can lead to memory leaks. ErrorCaptured is a bit of a newer hook. It's available in version 2.5 and up. And it's a little bit interesting because it actually takes in parameters, whereas the others do not. So we can see in this example, we have error captured, and it takes in error, which in this case is information about the exact error that occurred. It takes in VM, which is the component in which the error occurred. And it takes in info, which tells you at what point during that life cycle that error occurred. So we can find out if it was during render, if it was during an update, things like that. Error captured is also one that you can return false from. If you return false from an error captured hook, it will stop further propagation of that error. Whereas if you don't return false, it will continue propagating up the component tree, hitting any components that have error captured up above that, and it will reach a global error handler if you have one configured. So in this case, we can say, oh, okay, I saw something went wrong. We'll go ahead and let you know, but this is handled, so we don't need to worry about escalating this any further. There are two more lifecycle hooks, but before we get into those, we have to talk about keep alive components and what keep alive components are. So in this example, we have a puppy component and a kitten component. And we're using those dynamically with a component with is bound to whichever component is our active one. And then we have that wrapped in a keep alive tag. What this will do is when I switch between those views, it will cache whichever one I am not currently looking at, so that when I go back to it, it will have the same state. This can be useful in cases like switching through tabs. You don't want to overuse this because you don't want a user to be working with stale data. But there's obviously times for it, like when I want to know exactly which puppy I was looking at, and I don't want to go back through the list because I found my favorite puppy, or my favorite kitten if you are a cat person, that's okay. So keep alive components have two unique lifecycle hooks available to them. In this case, we're looking at activated, which will run when that component comes back into being the active one. It is coming out of a cached state. In this case, we're switching back to the puppy component, and puppies let you know that they're very excited to see you. So we want to say, we're going to show this welcome back message. The puppies can let you know that they missed you. On the flip side of that, we have deactivated, which runs when a component goes into being that cached component. This is a little bit more of a practical example than puppies, but we can see here, maybe you were at a certain point scrolled in the page, and when we switch to the other view, we want to be able to track where you were in that page, so we can go ahead and capture that so that when we activate that component again, we're ready to put it back so you can be at that same point. And that brings us to the end of our lifecycle hooks, and now we're going to get into these other pieces of the Vue instance. There's nextTick, v4, and refs that we're going to talk about. So the first one that we're getting into is nextTick, which you can use in interesting ways in a couple of the lifecycle hooks. What nextTick does is it returns a promise, and that promise will run when you get to the next update cycle in that component. So in this case, I'm going to say I want to set an error, and I'm going to set it, but I don't actually want to scroll that error container into Vue until I know the DOM has re-rendered. So we can go ahead and use a nextTick and know that once that nextTick is fulfilled, that error is going to be populated on the DOM. We're not scrolling somebody up to something empty. The chances of that happening with how fast Vue works is very slim, but just kind of some safety measures you can put in there. A little bit more practical uses of nextTick within the lifecycle hooks are on mounted and updated. Those ensure that the parent component has rendered, but it does not ensure that the child components have rendered. So you can use a nextTick inside of those lifecycle hooks to know that the child components have rendered as well. All right, this one's a lot, so I'm going to take a drink and let you guys read this for a second, and then we'll talk about it. So don't stress a lot about it, because it doesn't mean much without me saying a bunch. So when the requirement first came to use a key on your v4, I said, okay, whatever, I'll just put an index on here and get rid of this red squiggly line. And I didn't think anymore about what it actually meant until I started to run into some weird reactivity issues. And then I was like, what is going on? Spent forever just looking into what is going on in my code, and then I realized it's the key. It worked great when I was appending to the end of an array, because it was always creating a new index. The moment that I started unshifting and putting things at the top of the array and reusing that index, I started having problems. What the key actually does is it gives Vue a way to track which components in a v4 are new and which ones it actually has to re-render. So in this case, we can see that index would work great if you're just always pushing into the end. And an example we can see here to get an idea of what that reactivity issue would look like is with books. So we have a very simple book component, just shows us the title, and then whether or not something is checked out. Because we have to call to your local library or whatever, we're going to actually call and check the book status in a mounted hook and then set that in our component. This is fine if we're pushing into the end of an array. But as soon as we start adding to the top of an array so that your new book that you added shows at the top of your list, all of the sudden, if we're using index, that book is not considered new anymore. So it's not actually going to mount and make that call. It's going to show the checked out status of whatever book was in that list before yours. So this is where if you have a unique ID available on an object that you are iterating over, it is always safer to use that. I would 100% recommend doing that whenever it is available. Index is good, and it's actually what v4 uses by default, but it's really meant for cases where things are static or you're pushing into the end of an array. And this brings us to the last thing that we're going to talk about, which is refs. And we're not talking about the Vue 3 refs. We are talking about the refs that you can configure on your template. So we have 3 different examples here. We have one on just a regular HTML element on our div called myDiv. We have one on our puppy component that's myPuppy. And then we have one on a kitten component that's myKittens, and it's inside of a v4. We can look at the console logs here and see that we get different things back based on what we're putting these refs on. In the case of this myDiv, we just get back that HTML element. We can access the text content there, we can modify classes, whatever we need to do, but it just gives us back the element that we can access right from there. In the case of myPuppy, we get back the instance of that component. If you want to access the elements on there, you can do so with $el, or you can actually access methods and data items on there as well. In the case of myKittens, because that's on a v4, we actually get back an array of the full component instances. This gives you a lot of opportunities to be able to access components that are in your template and trigger methods on them if you need to. One really important caveat with refs is that they are not reactive. What this means is that if I had like a vif in here or a computed that was watching the value of a data item on a ref, it's not going to track that. The child component is reactive, absolutely, but my parent isn't going to know about those changes. So anything like that should be done through props or emitting events up. Refs are not meant to deal with anything reactive. They're just kind of a convenience piece. And that was all I had. I hope this was helpful. And thank you, guys. You can follow me on Twitter, check out my website. And thank you all for being here.